This is problem number 4 for assessment number 8. It says find all solutions to the equation. You can see that we have a trigonometric equation, but to solve this, we're going to solve this the way we solve any other algebra problem. We're going to start by taking care of the addition and then the multiplication, and then we're just going to evaluate for sine t. So let's subtract 5 to the other side. We get 2 sine t equals -1. Now let's divide by 2 on each side, so we get sine t equals -1/2. Okay, so we're trying to figure out what angle does sine equal -1/2. So let's grab the unit circle and take a look. We know sine is the y value. So if we look at the unit circle and look for the sine values to being -1/2, sine's going to be positive in the first and second quadrant. So we can just ignore those two quadrants. Let's look at the bottom quadrants. -1/2 is right here for the y value. So that means that one of our answers is t equals, and I'm not sure if they want it in radians or degrees, but let's go ahead and write it in both. That's fine. So t equals 210 degrees. Let's look for a -1/2 again. We see it here for a y value. It's 330 degrees. And then we can also say that that could be 7 pi over 6, right, in radians. And then 11 pi over 6 in radians. So those are the solutions for 360 degrees. But they say find all solutions to the equation. So that means they don't just want one revolution. What if I were to go around, let's say I go around one time and then 210 degrees. So I went around essentially, 210 and 360. So it's 570 degrees. What if I went around 570 degrees? Well, I'd be in the exact same spot, and that would be a solution as well. So to say find all solutions, we want to write these with some sort of expression to give us all the solutions. It's really easy to do. If we are at this angle, how do we get back to it? Add 360 degrees. Add 360 degrees, so on and so forth. Same thing with this one. Add 360. Add 360. So when I write my solutions, I say that t is going to equal 210 degrees plus 360 degrees n, 330 degrees plus 360 degrees n, and we can say the same thing here with 7 pi over 6 plus, but this time instead of 360, we know in radians that's 2 pi n, and we have 11 pi over 6 plus 2 pi n. Now remember, n equals, you could say that n equals number of revolutions. It's really just a way for us to describe that what happens if we continue to loop forever. So it gives you infinite solutions, but infinite solutions at those specific spots.